This is Chris Brown from Wallman Optical. Let's start over. Okay. This is Chris Brown from the Optical Help Desk. The presentation you're about to see is about wrap lenses. First of all, what we want to talk about is wrap frames and what signifies a wrap frame. Obviously, the wrap frames are going to curve around the front of the face a little bit more than a standard ophthalmic frame. And you can see on the diagram on the left that the frame is going to be wrapped a lot more than the frame on the right. When this takes place, we want to consider using a wrap lens along with the wrap frame. These frames are typically used for sports, sunglasses, and sometimes even safety frames. A lot of people that are using them for athletics, motorcycling, and obviously protection, again, for the safety frame aspect. What is a wrap lens? A wrap lens is designed to accommodate the frames with more face form. And so when a wrap frame is used, the patient is looking through the lens at a different angle than a standard ophthalmic frame. And so we want to accommodate for that so that their vision is as good optically as it would be in a regular ophthalmic frame. Wrap lenses do have a compensated RX, and what the compensated RX does is compensate for the increased face form. Most of the wrap frames are on an 8 base. Some of them are actually on a 6 base as well. And when you're, again, ordering these type of lens, you want to specify which base that frame is in need of. If you want, the lab can select the base for that frame as well. Here's an example of how a patient looks through a lens that is wrapped. On the right side, you can see the angle of gaze is different than it is on a regular ophthalmic frame. So even though the optical center is right in front of the patient's pupil, their angle of gaze is at an angle from that optical center, whereas in a regular ophthalmic lens, they're looking straight through the optical center. Again, the compensated RX is going to correct for this angle of gaze and make it a little bit, improve the optics for the patient using this lens. Wrap lenses are compensated for the wrap design, as I already mentioned. And here's an example or a list of some of the wrap lenses that are available for you. Kristen, I'm going to have to stop again. This is Chris Brown from the Optical Help Desk. Today we're going to do a presentation on wrap lenses. It's not going for. Okay. This is Chris Brown from the Optical Help Desk, and today's presentation is in regards to wrap lenses. First of all, what we want to do is determine what a wrap frame is. A wrap frame is going to wrap around the patient's face more so than a regular ophthalmic frame. And in this diagram on the left, you can see how the lenses curve around the face more so than it would in a standard ophthalmic frame. The people that would use a wrap frame design are generally interested in the fashion of a wrap frame. They might use it for sports, sunglasses. Some even use it for safety. A lot of motorcycle riders like it for the added wind protection when they're riding their motorcycle. Wrap lens is a lens that's different from a standard ophthalmic lens, and we want to use those when we have a wrap frame because it does accommodate for the face form on the frame. What a compensated lens does is it, excuse me, the compensated lens does, I'm sorry, we're going to have to start again. Okay. Hi, this is Chris Brown from the Optical Help Desk. Today's presentation is Let's Wrap About Wrap Lenses. In this first slide, what I want to present is what a wrap frame actually does. On the left side, you can see how the frame wraps around the patient's face more so than it does on a standard ophthalmic frame. The people that use wrap frames generally are interested in using them for sports, for sunglasses, safety. A lot of motorcycle riders will want them for added wind protection when they're out riding. But they're also used now as a fashion statement as well. Wrap lenses are used for wrap frames, and they compensate the RX for the increased wrap in the face form of the frame itself. If you do not use a wrap lens for a wrap frame, the patient's optics are not going to be as comfortable as they would normally like to have for their sunwear or outdoor protection. Wrap frames generally come in either an 8-base or a 6-base. You can either specify when you're placing the order, or you can have the lab choose the base curve that's most appropriate for that frame. A wrap lens, as you can see on this right diagram, is going to wrap around the face, as I mentioned earlier. But it also, when it wraps, changes the line of gaze the patient has through the lens itself. You can see how the optical center is positioned properly, but now with the change in the angle of the lens, they're actually looking through the lens at an angle compared to a regular ophthalmic lens. And this is one of the reasons why we use the compensated RX to correct for that. There are a number of different manufacturers that make wrap lens designs. There's the Shamir Attitude, Kbiko Wrap Design, Essler Wrap, Zeiss Wrap, and there's probably a few others out there as well. Again, they have a compensated RX to help the patient with optics when they have that lens wrapped around their face and change the angle of gaze. There are specific measurements that are taken into consideration for the compensated RX. Those measurements would be vertex distance, the panoscopic tilt, and of course the wrap angle of the frame. There are defaults used for most of the wrap lenses. If you do want to take measurements, you can specify the measurements as well, in which case then those would be programmed into the computer and the lens would be compensated or corrected even more so for that patient. Here's an example of one of the tools used. This is actually a Shamir tool, and it'll allow you to take those 3 measurements that we just spoke of in the last slide. There are a number of considerations when you're ordering wrap lenses. Actually, these considerations should be used on all ophthalmic lenses, but obviously the RX, the strength of the prescription, is a big determining factor on how big a frame you should choose. The frame size is important, their pupil distance, and then of course the lens material that's used. We do recommend polycarbonate or Trivex materials for wrap frame designs. We find that we have better success with the lens stability, and you're going to get a better, well, basically on some of the wrap frames require special edging as well, and so these lens materials seem to be more appropriate for those as well. All of these items that we just mentioned, the RX, the frame size, the PD, and then the lens material will be a factor in the lens thickness for the patient. It also impacts the weight and comfort that they're going to have. And most importantly for patients is their appearance as well. PD placement is huge, especially with thicker lenses. And in this top diagram, what we've done is we've shown a picture of a frame and centered the pupils within the lens design. And so you can see at this angle, the thickness is not going to be as great as if we have a narrower PD on the bottom diagram, where it's decentered more. And as you decenter the pupils or the optical center of the lens, you expand the thickness of the lens on the outer edge. And of course, the more decentration, the thicker the lens is going to be. Typically on an ophthalmic pair of glasses, we use we recommend a decentration of about 2 to 3 millimeters per eye. With wrap frames, we would suggest maybe 4 to 5. It is going to be a little bit more decentration on a wrap frame just by design, but again, if we can keep it to a 4 to 5 millimeters, you're going to have a better looking pair of glasses, and the patient's going to be much happier with the results as well. PD placement, how to calculate decentration. When you're taking a look at the patient's selection for frames and lenses, to figure out the amount of decentration, you would add the frame PD, which is the frame eye size, and the DBL, and then you add those two together and then divide it by 2, and then subtract the patient's PD. And so in this particular example, we've got a frame size of 68 for the eye size, 16 for the DBL. So we add those two together and we get 84 millimeters. Subtract the patient's PD of 63 from 84 and divide that by 2, and we have 10.5 millimeters of decentration per eye. So you can see that's well above the 4 to 5 millimeters that we recommend. And if the prescription is pretty strong, the thickness is going to increase quite a bit as well. So that would be a sign to suggest maybe a smaller frame for the patient. Here's an example too. If you have too much decentration, not only do you run into a thicker lens, but you may end up in a situation in this bottom example where you don't have enough lens thickness in the blank itself to actually have it cut out or go all the way to the edge of the lens. And if you did, it would even be thicker than what it looks like in this example here. Another situation that you have is you may not have, in this diagram, enough lens blank size to actually reach out far enough to be able to be mounted into the frame. In this particular case, it would not be large enough diameter to have the drill mounted lens, well, the hole for the drill mount within the lens itself. Again, the smaller the eye size, the thinner the lens is going to be. You can see if the frame size was the size of this box here, the lens thickness would be much thinner than if you went with the frame that's in this picture itself. Another thing that you want to consider, again, is ordering the wrap lens with the wrap frame. If you were to place an order and not tell us that it's a wrap frame, send the lenses in first, or send the lens order in first, and then the frame is to follow, and we don't know it's a wrap, we might put a standard base curve on that lens for the RX. And then when we try to put it in the frame itself, now we find out it's a wrap frame, and what will happen is the flatter curve on the lens is going to flare out the sides or the temples, the end pieces of that frame, and it's not going to fit the patient properly. It's also going to take away from the integrity of the frame design and the way it looks for the patient. It will no longer have that wrap look. So the patient won't be pleased with it. And again, some of the wrap frames require an 8 base, some require a 6, and you can let the lab determine that if you want, or you can specify, but it's best to allow enough time so that the lab can see the frame and make sure everything is going to work properly with that RX as well. Other considerations, sometimes you probably have all experienced a patient that's real sensitive to change. Maybe it's a base curve change, maybe it's just a change from one pair of glasses to another with the same RX, or maybe you have a patient that every time they get a new prescription, it takes time for them to adapt to that new lens, in which case I would not suggest the wrap lens designs as an option for them. Basically what you're doing again is you're changing the way they look through that lens, and if they're that sensitive in the first place, more than likely they're going to have a challenge wearing a wrap design. My own prescription is not very strong, and when I put on my wrap lenses, I do notice a few minutes where my eyes have to take to accommodate the wrap design. And after a few minutes, then it's fine. But even I notice it, and I can switch glasses pretty easily without noticing it. And again, when I put on the wrap lenses, there is a few minutes of adaptation. So keep that in mind. The other thing is, again, with wrap designs, you want to be very conscious of what the patient's expectations are. You know, they're looking at the lenses with plain old lenses in it at your office, and then when they get the regular glasses or the glasses with their prescription in it, they're obviously going to look a lot different with the thickness of the lens. And so you want to give them realistic expectations on that as well. Some wrap frames do require special edging, and if you're unsure of whether or not the wrap frame is going to hold an RX lens, you can send it into the lab and have the lab evaluate it and then make recommendations from there. But some of them require what we call a shelf or a step bevel. They don't have a standard V bevel like or height of bevel that you would use on a regular ophthalmic metal frame. But it actually is like a box or a shelf, and I've got an example here in the next few slides where I can show you what a shelf bevel will look like. Obviously, there's extra charges for drills, and then some are groove mount rimless. Some do still require a V bevel. Here's an example of some shelf beveling. In this particular case, you can see that the frame, actually the lens, front of the lens extends beyond the edge of the eye wire for this particular frame. And with a plano lens, it looks really good. You don't have this white ring around it because you don't have to do a shelf bevel. It just fits in the frame properly. But when you have a prescription where the prescription is now thicker than a plano lens, it's thicker at different angles of the lens as well, or different axes. You can see what we have to do with this special edging equipment is put this shelf layer in it so that we get the right prescription. And then this is the portion out here that would fit into the lens or the frame itself. This would be about the thickness of a normal plano lens. What this does is it creates the frosty look that you see on the edge of lenses, but now it's in a much larger section, and it's going to create the white ring around it. Now this is hidden somewhat by a tinted lens, but it still will be a little bit noticeable, and so you want to be careful on some of these designs to, you know, make sure the patient's aware of it and that you don't end up ordering something that they're going to really dislike once they get it. The drill-mounted lenses obviously require polycarbonate or Trivex materials. Those are going to be the safest lens to go with. And again, that's what we recommend for wrap frames anyway. And again, be aware of the fact that there are additional charges for both drill mounts and shelf edges. Another consideration is if you had a plus power lens and you're putting it in a wrap lens and then you're adding the drill mount, you're going to end up making the lenses a little bit thicker, so there's enough thickness on the outer edge to do that drill mount as well. The thickness of the lens is sometimes hard to explain to patients, but what we've done is we've given you here a website to go to. It's opticampus.com, and on this website you can go to the tools and then to the thickness calculator, and this calculator allows you to plug in the patient's RX, their PDs, the frame size, and then the material, and get an estimated lens thickness. And that way you can show the patient without telling them, you know, no, you shouldn't go with this pair of glasses. You can say, you know, Johnny, this particular lens with your, or frame with your prescription is going to be 8.5 millimeters thick. Are you going to be comfortable with the way that looks and the weight of that pair of glasses? Or, you know, my professional opinion, I think that we might be better if we go with a little bit smaller frame. And you can give them a little bit more information, so it's not like you're just telling them no. You're giving them realistic expectations, and then again showing them what to expect with the end result if you do go forward with that order. And again, you have to consider it lens thickness, or the thickness of the blanks. Will there be enough lens thickness to actually make that pair of glasses? In showing the patient how thick 8.5 millimeters might be, you can just hold up your PD ruler and show them how thick it'll be on the PD ruler. And then they might say, well, gosh, my regular glasses aren't that thick. How come these will be that thick? And then again, you can explain, well, with the larger frame size and the wrap design, you're going to end up with this much more thickness because you get that much more lens to make the whole pair of glasses work for you. And if the patient's concerned about thickness, you, again, get a smaller frame and help them make a better decision. You can also, if they're interested in a specific color lens and they want a wrap design, but it's not the best thing, you know, it doesn't hurt to put them back in an ophthalmic frame so that they get the best results and are happy with their end selection. If you have a situation where they're kind of borderline and you're not real sure, what I would recommend that you do is you have the choice that the patient has for selection number 1. You can send it to the lab, have us give you your information that you want, whether or not it's a good idea to go with the first selection, but maybe have a second selection in mind, have all the measurements and everything ready, so if the first choice is not a good option, you don't have to call the patient back in and have them pick out another frame and take new measurements, that type of thing. It's already in place, and you can just call the patient at that time and say, you know, it's not going to work. The lab says we shouldn't go this route, and so we're going to go with your second choice in this particular situation. Here's a picture of the opticampus.com tool, and again, as I mentioned, you plug in the prescription. In this particular case, we used a +250 with a -50 cylinder and a 100 axis. The PDs were 58 for distance PD, and then we had the eye size, the bridge size, and then shows polycarbonate material. And with that frame size and that prescription, clicked on calculate, and it gave us a center thickness of 6 millimeters. Now, the 6 millimeters in the center is quite wide, but it also said on the outer edge 1.9. Now, if you had a drill mount, it might even make it a little bit thicker on the outer edge, just so that you got enough thickness there for the drilling. 1.9 is probably okay, but you want to be careful of that and make sure you consider that when you're doing plus lenses, if you have to add a little bit to the outer edge. We've also got some examples of what will happen. We've selected a power of -3. We've got different PDs for different patients, and then we selected 2 eye sizes, a 65 eye and a 60 eye frame. And just to give you an example of what happens with the lens thickness on the outer edge, with a 66 PD on a 65 eye frame, you're looking at 6.7 millimeters, where if you dropped it down to a 60 eye frame, it's only 5.4. And you can see it changes as the PD decreases, it gets thicker. And so again, decentration is huge. So a lot of opticians will say, well, can you give me a power range for these particular frames? Well, I can give you a power range, but what if the patient's PD changes? That's going to change the way that pair of glasses look. And yes, we can maybe make the lenses, but is it something that they're going to really like as an end result? And so you want to be aware of that. In this example, we used a -2, and you can see the lens thickness is less than a -3, but it's still, as you reduce the PDs for the patient, you're increasing the lens thickness. In this particular example, we took a plus power, and this is a +2. Again, the same PDs, same eye sizes, but in this particular case, we measured center thickness and then nasal thickness. Now, when you decenter a lens on a plus lens, you're also making the nasal edge of the lens thicker. And what can happen a lot of times, if it's too thick, you may not have enough room on that nasal edge to even adjust the nose pads if it has adjustable nose pads. So you want to be aware of that as well. Make sure that the design is going to work with the lenses when you're evaluating these orders. And here's the same example, only using a +1 power. Okay, as a summary, basically, we all know that wrap frames are growing in popularity. They're not going to go away, so we just need to be wise in helping the patients select a good product for their glasses. make sure that we give them realistic expectations so when they get their glasses, they're happy with the end result. And we don't want to just say no. We want to offer other alternatives. We want to give them good information so they can make an educated decision and not feel like you're just saying, no, you can't have this. We're saying, gosh, I think this might be better, and here's why. And you can show them what the thickness is going to be. You can explain how it's going to look if they have a shelf edge. And you can give them everything that they need to consider in making a good decision. And that's it for our wrap lens webinar.